Today's lesson is on two variable inequalities, meaning we'll probably have an x and a y, and we'll have to graph it. Before we get too far, let's go ahead and describe a couple of things here. We have a coordinate plane here, that's your x and y axis, and when you have a line that you graph on a coordinate plane, you actually cut the plane into two half planes, with the line actually being the boundary of the two half planes. When we are talking about a linear inequality, we have to graph the line and also shade, kind of like we had to shade on the one variable inequalities where we put an open circle or a closed circle and then shade it to the left or to the right on the number line. Now we'll have, instead of open circles, we'll have a dotted line like this one on the left. If it's a or equal to, where it would be a closed circle, we actually have a solid line like this one on the right. After that, we'll have to shade either above the line or below the line. So I'm going to start out being the math teacher and tell you how to solve this, and then I'm going to tell you kind of a quick way to look at it. So we should all be able to graph a line by now. We only need 2 points to graph a line, and you can get that points through a lot of different ways. We could actually choose an x value, an input value, put it into the equation, get an output, plot that point, do it again. But usually when it's already written in the y equals mx plus b, we get our 2 points from the y-intercept. So we come down here, we put a point at -1 on the y-axis. Then we use the slope, 3/1, to get our second point, and then we draw our line. After we draw our line, either dotted or solid, depending on the inequality symbol, we have to figure out which side of the graph to shade. The math teacher is always going to tell you to pick a point that's not on the line. It can be any point. The most common point is 0, 0, but sometimes your line is actually pretty close to 0. And if you're doing a sketch, you got to be kind of careful. So make sure that you know for sure 0, 0 is not on the line. Substitute it back in, and if it's a true answer, like this one was, 0 was greater than -1, I'd put a little true right there. You can't really see that because it's in yellow. Let's put it in blue. Put a little true right there, and we should shade over that point. Now, the non-teacher in me tells you that just like when we had x is greater than 5, if we kept the variable on the left-hand side, we were able to look at the greater than symbol and say, oh, it shades to the right. If it was a less than, we shade to the left. Well, we can do the same thing here, but here we're talking about functions. So we want the function on the left. Well, what variable can I replace an f of x with? I can replace it with a y. So as long as your y is on the left-hand side, we can look at the symbol greater than or equal to, less than or equal to, and figure out which way to shade. Think about greater than. We're talking about the y values being greater. We want to shade up or above the line. Less than, the y values want to get smaller, so we want to shade down or below the line. So the math person wants you to choose a point, plug it in, see if it's true or false, shade over if it's true, shade away if it's false. But the realist in me says, hey, if you can get the y by itself on the left, just look at the symbol, it'll kind of help you out. All right, so I want you to pause the video here and see if you can do these two, and then start it back up and you'll see what they look like. And here's what your two graphs should look like. We can use two variable equations to solve word problems. Here we have a fair that we want to go to, that we have to buy some tickets. Each ticket is 25 cents and we have 15 bucks, so I know I can buy 60 tickets. The first thing you should always do with a word problem is to define your variables. And we have small ride tickets and large ride tickets. So we have small rides, we'll call X, large rides we'll call Y, and then we're gonna multiply them by the number of tickets each of them will need and set it less than or equal to 60 because we have 60 tickets. We don't have to spend all 60 tickets, but we could if we wanted to. From there, we're gonna graph it. But we're only going to graph it into the first quadrant, and you'll see why in a second. So we used our x and y intercepts, seeing how our equation was in standard form. Standard form makes it real easy to do x and y intercepts. But if you look at my graph, you'll notice that I didn't go to infinity. You don't see the arrows. And that's because this is a real world problem. And on the left-hand side of your graph, this way, are negative numbers. You can have negative small rides. And below this graph, this way, would be negative large rides. And that doesn't even make sense. So we just did it into the first quadrant. So this shaded area, this yellow shaded area, are all the different ways that you could ride the rides and not spend more than 60 tickets. In reality, though, it's not totally shaded in because you couldn't be like right here. I couldn't ride 2.4 small rides and 7.9 big rides. That doesn't make sense. So really the graph, we always shade it, but it's really all the little corners, like the 1, 2, 2, 3, 3, 7, so on and so forth. All right, so moving on from graphing a line and then shading, we're going to go ahead and graph an absolute value and then shade. So the first thing we want to do is to get our absolute value equation in the right form. It's a function, so I want to say y equals. So I'm going to move that 1 over first by subtracting, and that leaves the negative in front of the y. Then I'm going to divide all 3 terms, because there's only 3 terms. There's 1 on the left and 2 on the right. I'm going to divide all 3 terms by a negative, and it looks like this. And now we have our vertex. Our vertex is h comma k. The h is inside the parentheses with the x. Remember, there are hidden parentheses right here. And to take that 2 out, we really have to set that parentheses equal to 0, move the 2 over. So really what we're doing is we're changing the sign of the 2 and dividing by 1 that's in front of the x. And then our k is the number on the outside. We don't have to do anything to that. So there is my vertex. Once I have my vertex, I can go ahead and graph it. Here's my vertex right, oops, hold on a second. Here's my vertex right here. And then I look at the A, this guy right here, to tell me, remember that's the, air quotes, slope. So the slope is telling me to go down 1 over 1. So I go down 1, over 1, put a dot, down 1, over 1, put a dot, and then I can make my V, and we dot it because of the or equal to is not there. So it's like it's a dotted line. Now we have to shade. We're supposed to pick a number. I like 0, 0 if I know that we didn't go through. And we're going to substitute it back into the original equation. 1 minus 0 for the y value. 0 plus 2, 0 for the x value. 1 minus 0 is 1. 0 plus 2 is 2. The absolute value of 2 is 2. Is 1 less than 2? It is true. So I put a true there, and notice that I shaded over the true. Again, that's the math person in me. Tells you to take a point, substitute it in, see if it works. The realist in me says, hey, if you get it into function form where you have f of x is less than or greater than or whatever you have, remember that f of x is a y, then you can just look at the symbol and you should know where to graph. If it's a greater than is up, so you grade above the V. If it's less than, it's below, so you grade shade below the V, and that's kind of the quick and easy way to think of it. Go ahead and pause your thing here and give this one a try. Okay, so here we go. The first thing I did was I got it into f of x into function form, so the y all by itself by moving the 4 over. Then I have my vertex. Remember, I take the negative 1 out, and I go, it becomes 1 comma 4, so I put a dot at 1 comma 4. I look at my, air quotes, slope, and it's a 2 over 1, positive, so I go up 2 over 1, up 2 over 1, make my V. Then I say, okay, remember this is the math person, I'm going to pick 0, 0, put it into the original equation, solve it out, and go, hey, wait a minute. Negative 4 is not greater than 2, so that is a false statement. So I did not shade over this false statement, so I really only have 2 places to shade, either outside the V or inside the V. So if the false was outside, I had to shade inside. Now the realist in me goes, well, here where I got the y by itself, I had a greater than sign. Greater than is up, so I had to shade up, and that would be inside the v. So either way you do it is fine with me. And the last thing we're going to do is to work backwards. I'm going to give you the graph, and you have to give me the function, the inequality that created that, right? And so there's three things that you have to fill out. You have to figure out the a, the h, and the k. Well, these two guys, the h and the k, are the vertex. So that's the first thing you want to figure out. The vertex is right here. So it's 1, 2, 3 over, 2 down. So I think it's 3, -2, right? And then this is the air quotes slope. So if I go from this vertex to the next corner, it's right there. So the slope is 1. From there, I can fill in all my things. Remember, it's supposed to look like this, y, and then I have an a, x minus h plus k. I left this blank because it's not an equal sign anymore, so let's fill in what we know. I'm going to put a 1 right there. Do you don't have to put the 1? No. To put the h in there, remember, change its sign, so it's a +3, so it becomes -3. The k becomes -2. So now I just have to look back at this. Well, we shaded up, right? Up is greater than. Now I just got to figure out, is it greater than or equal to, or just greater than? Well, we dotted the line, so there's no or equal to. That's how easy it was, right there. And that completes this lesson.